Hello and namaskar to all the viewers. I, Ms. Rupali, welcomes you all on my YouTube channel, that is Women's Physics Tutorial. So already we have started with the basic science course. In that we are looking or we are focusing on one of the part of basic science, that is physics. As you all know that this course is there for you in the first semester to all the first year students who are doing their diploma in engineering and technology from any branch. So let's start with the unit 2, and the name of unit 2 is electricity, magnetism and semiconductors. So this unit is categorized into 3 parts, we can call it. Okay, so let's see the syllabus of unit 2 in detail. So these are the subtopics of unit 2. In the 2.1, it includes the concept of charge, Coulomb's inverse square law, electric field intensity, potential and potential difference. Now already in the 9th and 10th standard you have gone through all the basic concepts, okay, like what do you mean by a charge, what is an electric field, what is potential energy, what is potential difference. So you all have learned that. Next is magnetic field and magnetic field intensity and its unit, magnetic lines of force and magnetic flux. Next 2.3 is electric current, Ohm's law, specific resistance, laws of series and parallel combination of resistance, heating effect of electric current. 2.4 is conductors, insulators, semiconductors, energy bands, intrinsic and extrinsic semiconductors. And 2.5 is PN junction diode, IV, that is current voltage characteristic of PN junction, applications of PN junction diode. So already you have know most of the part of this unit 2, okay, but there is a question in your mind that why this part is added into this course, that is diploma in engineering and technology. So let's understand that first. What is the significance of having this unit 2 in your syllabus? So you all know that as an engineer or as an technologist, you need to deal with the different devices or the electrical equipments, right? So all the devices like the electric motors, electric equipment, transportation devices, they need the knowledge and the understanding of electricity and magnetism. So through this course, you will be getting the knowledge and understanding of the electricity and magnetism, which you can apply it whenever you will face the problems. Get it? That's why this is added into your syllabus. Next significance is electronic gadgets such as the mobiles, yeah, the need of human being nowadays, computers, power supplies, electronic circuits, sensors, they all require the understanding of semiconductors. And that's why this subject is there, okay, which is very familiar to you, yeah. And this is the purpose of having these subtopics in your syllabus. Now let's start with the syllabus. So let's go. Now the first concept in this unit 2 is charge. Now you have already know this concept, right? आपको सब कुछ पता है कि चार्ज क्या होते हैं, कितने टाइप्स के चार्ज होते हैं, what are the examples of the charge. Yes, so let's revise it for you. So बहुत सारे आप लोगों ने ये ऑब्जर्व किया होगा कि when you comb the dry hairs, okay, you feel the crackling sound, as well as when you remove your sweaters in the winter, you feel the crackling sound. Yeah. Now my question is, why this crackling sound is produced? Or are so this crackling sound is produced because of the electrical charges. Now how these electrical charges are produced? So yes, they are produced due to the friction between the two bodies. Like, for example, you're combing your dry hairs with the comb. So there is a friction between comb and your hair, right? So that friction leads to the crackling sound. And because of the friction, the electric charges are produced. Okay. So due to the frictions, the electrons get transferred from one substance to other substance and making them charged. Now, yes, every matter which is present in your surrounding, they are made up of the minute microparticles, right, which consist of the subatomic particles. And because of that, the charges gets transferred from one body to the other body. And because of that, you hear the crackling sound. So understood the concept ki why you heard the crackling sound? So that is because of the electric charges produced due to friction between the two bodies. And due to friction, electrons get transferred from one substance to other substance, making them charged. Now whenever there is no friction, obviously the charges are at rest, they are stationary, they are in equilibrium, because nothing external force is acting on them. The external force is not disturbing that body, and hence there is no transfer of charges. Okay, but when there is a friction, yes, there is a transfer of the electrons, or we can call the subatomic particles, from one body to the other body, and that leads to get that body charged. Now electric charge is basically the property, we can call this as a physical property of subatomic particles. Okay, so every body, every matter is made up of the particles. So ये जो electric charges है, that is the property of the subatomic particles that causes it to experience a force when placed in an electric and magnetic field. Okay, so if it is asked to you that what is the definition of electric charge, so you can say that it's the property. Now अगर आपको और डिटेल में लिखना है तो you can write it is the physical property of the matter. Okay, or it is the property of the subatomic particles that causes it to experience a force when placed in electric and magnetic field. Now there are two types of charges, positive and negatively, commonly carried by charged carriers, that are protons and electrons. So we all know that whatever things which are present in our surrounding, that all are made up of the smallest, or we can call as the tiny particles, whose further division is not possible. Though at the microscopic level, if we'll see these particles, which we call them as the atom, they consist of the subatomic particles. So these atoms, they have a center which is known as the nucleus, and that nucleus has protons which are positively charged and the neutrons which are neutral. Whereas yes, electrons are also there which are revolving around the nucleus, which are electrons. Okay, so these are the charges which are present inside an atom. Okay, so these are the two types of charges we can call. Now the substances who receives the electrons, they become the negatively charged, and the other substance who loses the electron will become positively charged. Okay, and how to measure the charge? So like we measure the other physical quantities, yes, charges can also be measured. Yeah, and for that it has a unit which is known as the coulomb. So this is all about the charge. Now the next concept from this unit, that is Coulomb's inverse square law. So we have seen that there are two types of charges, okay, which do carry the charge, positive and negative charge, whereas neutrons, they are neutral, they don't have any charge on it. Okay, so the two charges which are namely positive and negatively charged, उनके बारे में एक चीज़ जो है वो ऑब्जर्व की है, that we all know that first thing, that is like charges repel each other, whereas unlike charges attract each other. ये समझने के लिए we'll consider one more example, like the bar magnet. Okay, consider two bar magnets. Each bar magnet has a north pole and south pole. If you will bring two north poles of both the magnet towards each other, obviously there will be a repulsion. Whereas if you will bring the north and the south pole of the magnet towards each other, then yes, there is an attraction. So from it is clearly understood that like charges repel each other, whereas unlike charges, they attract each other. But from this we understood that yes, every body that is exerting a force on the other body. Yeah, both the bodies or whatever bodies are present, they all exerts a force on the other bodies which are present in their surrounding. And the force of attraction or the repulsion between two charge which are separated by distance r is given by this Coulomb's inverse square law. So here for that we'll consider two charges, q1, q2. Now already I have said that if the both the charges are positively charged, then the force of attraction between them is repulsion, and therefore here you can see there is a repulsive force between the two objects. Whereas if the bodies are oppositely charged, or here the two charges are oppositely charged, then there is a force of attraction between the two charges. Okay, so this you have to keep in your mind. Now before actually starting to the derivation of this Coulomb's inverse square law, let's see why this is known as the Coulomb's law or Coulomb's inverse square law. So you can call the Coulomb's inverse square law as Coulomb's law also. Okay, this is the law of physics that defines the amount of force between two stationary और इलेक्ट्रिकली चार्ज पार्टिकल. ये आपको ध्यान में रखना है कि what Coulomb's law defines. So it defines the amount of force, कितना force है between the two stationary हो या electrically charged particles हो, and that's why it's also known as the electrostatic force. Okay, so ये जो force है इसको आप electrostatic force भी बोल सकते हो, और simply you can call as the force, okay, between the two charged particles, electrically charged particles, or if the charges are stationary. Now this Coulomb's law, it was discovered by Charles Augustin de Coulomb in 1785, and hence the law and the associated formula was named after him. So you got the point why this is known as the Coulomb's law or the Coulomb's inverse square law. ये जो inverse square law है, why this term is used, ये आपको और अच्छे तरह से समझ में आएंगी when we'll see actually the derivation. Now let's focus on the statement of the Coulomb's law. So this Coulomb's law states that the magnitude of the electrostatic force, जैसे मैंने पहले ही बोला कि yes, charges they have the unit or and they possess a magnitude, 1 coulomb charge, 2 coulomb charge, like that. So this Coulomb's law states that magnitude of the electrostatic force of attraction or repulsion between two electrically charged bodies is directly proportional to the product of the charge of the charged bodies and inversely proportional to the square of the distance between the center of the charged bodies. तो ये जो स्टेटमेंट है, इस स्टेटमेंट में आपको क्या ध्यान में रखना है कि दिस Coulomb's law, it talks about the electrostatic force between the two charged bodies. Yes. So this force is directly proportional to the product of the charge and it is inversely proportional to the square of the distance between the center of the charged bodies. So ये अगर दो bodies है, this is the center of the body, so we are talking about the force, okay, or we are measuring the distance between the two bodies, that is from the center of the two charged bodies. So got the statement. I'll revise the statement again. That is, Coulomb's law states that the magnitude of the electrostatic force of attraction or repulsion between two electrically charged bodies is directly proportional to the product of the charge of charged bodies and inversely proportional to the square of the distance between the center of the charged bodies. So ये हमने देखा. तो पहला जो हमने पढ़ा था, that is force is directly proportional to the magnitude of the charges, that is Q1 into Q2, and it is inversely proportional to the distance. So consider the charges Q1 and Q2 are placed at a distance of small r. So we can say that F is proportional to Q1, Q2 upon r square. Now here we will equalize the equation by taking a constant which is k. K is known as the proportionality constant and which depends on the medium. आप कौन से मीडियम में चार्जेस को प्लेस कर रहे हैं, वेदर दे आर इन एयर मीडियम और आपने उनको वाटर में रखा है, इट डिपेंड्स ऑन द मीडियम, that constant k, and the value of k is 1 upon 4 pi epsilon naught epsilon r, okay, where this epsilon naught is the permittivity of free space and it is a constant. So its value is fixed, that is 8.854 into 10 to the power minus 12 farad per meter. And epsilon r, that is relative permittivity of the medium between two charges, which is 1 for the air. Okay, so ये जो पहला जो इक्वेशन है, that will become now electrostatic force F between the two charged bodies equal to Q1 Q2 upon 4 pi epsilon naught epsilon r into r square. And as we are considering the air medium, so epsilon r की value यहाँ पे 1 है. That's why we write here F is equal to Q1 Q2 upon 4 pi epsilon 0 r square. Now in this equation 2, if Q1 and Q2 is equal to 1 coulomb and the distance between the two charged bodies is 1 meter, then the value of force between the two charged bodies will be equal to 1 upon 4 pi epsilon 0. And if we'll put the values of all the constants, like we know the value of pi, we know the value of epsilon 0, then that value will become 8.99 into 10 to the power 9 Newton. And we just equalize that to the 9 into 10 to the power 9 Newton. Okay, so from this we can define 1 coulomb or the unit charge, and it is that charge which, when placed in air at a distance of 1 meter from an equal and similar charge, experience a force of 8.99 into 10 to the power 9 Newton. Okay, so this is the formula of Coulomb's law, and from this it is clearly noted that force depends on the magnitude of the charges and the distance between the two charged bodies. Now, how this force will get affected, that we'll see. अगर चार्जेस कम ज़्यादा होते हैं तो क्या होता है, अगर डिस्टेंस कम ज़्यादा है तो क्या होता है. सो हाउ दैट फोर्स गेट्स अफेक्टेड ड्यू टू change in the magnitude of the charges and change in the distance between the charges, that will see. So उसमें पहला जो है, that is related to the charges. अगर चार्जेस कम ज़्यादा होता है तो क्या होता है, लाइक सपोज इफ वी हैव टू चार्ज बॉडीज, वन इज पॉजिटिवली चार्ज्ड and one is negatively charged, then obviously we know that there is a force of attraction between them. So they will attract each other if they are kept at a certain distance from each other. Now let's consider this first case. If we increase the charge of one body, पहले क्या था, both the bodies उनकी मैग्नीट्यूड जो थी वो सेम थी. नाउ इफ वी इंक्रीज द चार्ज ऑफ वन बॉडी कीपिंग द अदर अनचेंज्ड, देन व्हाट विल हैपन. नाउ यहाँ पे ये चार्ज है Q1, ये है Q2. Okay, one is positively charged, another is negatively charged, both have the same magnitudes. Okay, now Q1 के जो चार्जेस थे दैट आई हैव इंक्रीज्ड और Q2 को मैंने एज इट इज़ वैसे ही रखा, तो व्हाट विल हैपन, whether the force of attraction will increase or decrease. So obviously force of attraction will increase. Similarly अगर मैंने ये किया, I'll keep Q1 as it is, and if I'll increase Q2, then what will happen? So if we increase the charge of the second body keeping the first one unchanged, then also obviously the force of attraction between them will increase. Okay, so from this we can say that the force between the charged bodies is proportional to the charge of either body or of both. Okay, तो ये समझ में आ गया पहला आपको. नेक्स्ट जो है दैट इज if will keeping the charges fixed at Q1 and Q2, and if we bring them nearer to each other, then the force between them will increase. ऑब्वियस है, एक अगर पॉजिटिव चार्ज है एक नेगेटिव चार्ज है, दोनों को मैंने नज़दीक लाने की कोशिश की तो बोथ द चार्जेस विल गेट अट्रैक्टेड वेरी स्ट्रांगली, राइट? सो फोर्स ऑफ अट्रैक्शन विल इंक्रीज, एंड इफ यू टेक देम अवे फ्रॉम ईच अदर द फोर्स एक्टिंग बिटवीन देम विल डिक्रीज. जितना आप ज़्यादा डिस्टेंस बढ़ाओगे उतना क्या होने वाला है, फोर्स ऑफ अट्रैक्शन कम होने वाला है. So here we have seen two cases related with the size of the charge. Okay, in short we can talk about the magnitude of the charge. पहला जो है तो मैग्नीट्यूड एक का कम किया दूसरे का सेम रखा और वाइस वर्सा. एंड सेकेंड केस में हमने क्या देखा कि वी हैव केप्ट द चार्जेस फिक्स्ड. वी आर जस्ट चेंजिंग द डिस्टेंस बिटवीन देम. वी आर कीपिंग देम क्लोजर एंड वी आर टेकिंग देम फार अवे. तो क्या होता है, तो फोर्स पे क्या उसका अफेक्ट होने वाला है. ओके, दैट वी हैव सीन. सिमिलरली वी कैन टॉक अबाउट द सेकेंड थिंग दैट इज़ रिलेटेड टू द डिस्टेंस, कि अगर डिस्टेंस कम ज़्यादा होता है तो फोर्स कैसे अफेक्ट होता है. सो इफ द डिस्टेंस बिटवीन द टू चार्ज बॉडीज इज d, it can be proved that the force acting on them is inversely proportional to the square of the distance that we have already talked. Now this development of force between two same charged bodies is not same in all the mediums. As we discussed in the above formula where epsilon r would change for the various medium, so depends on the medium creation of force can be varied. So यहाँ पे मुझे और एक बात आपको बोलनी है कि we have talked that this force is directly inversely proportional to the distance square. तो यहाँ पे क्या हो रहा है, देखो ये दो बॉडीज है. ओके, नाउ इफ आई इंक्रीज द डिस्टेंस बिटवीन टू बॉडीज तो फोर्स क्या होने वाला है, कम होने वाला है, बिकॉज बोथ आर इनवर्सली प्रोपोर्शनल. एक घटेगा तो दूसरा बढ़ेगा एंड वाइस वर्सा. अगर ये डिस्टेंस मैंने डबल कर दिया तो क्या होगा, फोर्स इज proportional to 1 upon 2d square, so that will become 1 upon 4d square. तो force क्या हो गया, it decreases 4 times when I increase the distance twice. समझ में आ गया. अगर मैंने distance ट्रिपल टाइम बढ़ा दिया तो फोर्स क्या होने वाला है, 9 टाइम्स कम होने वाला है. ओके, ये चीज़ जो है वो आपको ध्यान में रखनी है. एंड देयरफॉर दिस कूलम इज ऑल्सो नोन एज कूलम्स इनवर्स स्क्वायर लॉ, बिकॉज ये जो फोर्स है इट इज़ डायरेक्टली रिलेटेड टू द डिस्टेंस बिटवीन दी चार्जेस. ओके, तो ये एक थिंग जो है वो आपको ध्यान में रखनी है. सो गॉट ऑल द थिंग्स रिलेटेड to Coulomb's law. Okay, so this is the end of Coulomb's law.